Hello, everybody, and welcome. Very excited to be with you here today in this brand new free class where we're going to be talking about breath and biowater and how to leverage the quantum elements and the new biology of the mitochondria into your superhuman energy era. And speaking of what we're going to be covering, let's talk about today's agenda. First, we're going to talk about what we call the quantum elements. What are they, and how do they influence your body's energy production? And specifically, we're going to look at that through the lens of cellular respiration that happens in the mitochondria. We're also going to be talking about ATP, what you might currently know as the energy currency of the body, and why it's actually not. It's sort of fake news. Sort of. We'll get there. Then we're going to go into the fascinating connection between water, breath, and plasma when it comes to our health and in particular our energy. And so if you're not sure what that word is, what plasma is, no worries. We're going to talk about it. Okay, so let's learn about it. Let's talk a little bit more about how this works. Let's get into our first agenda item here and talk about the quantum elements and how they influence your energy production in the mitochondria. The four most important quantum elements are water, air, earth, and light. So I should say that there are other quantum elements, things like sound and consciousness and EMF. But these are the primary ones. And in case some of you need help with this word quantum in this context just means subatomic. So this is just speaking to the scale that we're looking at these elements on. It's a very, very small one in this case, okay? Now, what do you think that all of these elements have in common when it comes to your health? It's the mitochondria. They all impact the mitochondria, and this is the relationship that we're going to examine today. But in today's class, I'm going to be focusing predominantly on the water and air elements and how they talk to the mitochondria. We are going to touch briefly on light and earth as well, but we only have so much time. So the brunt of our focus is going to be on water and air. Now, before we delve into this, let's just review the mitochondria a little bit. So here we have a crosswise view of a cell. And we see these little organelles inside of the cell that are red and sort of pill-shaped. These are the mitochondria. And I'm guessing that you learned in high school that the mitochondria are the powerhouse of the cell. And this is true. But it's actually not true in the way that you likely think. So the way that mitochondria generate energy for the body is through a process called cellular respiration. This is the process through which the food we eat, all the way over here, is turned into usable energy for the body. And in case this diagram hasn't conveyed it to you, this is an intricate process, right? Food is converted into glucose via digestion, and that glucose enters the cell and then the mitochondria. The glucose is converted to pyruvic acid so that it can enter the Krebs cycle. And then it's converted into an intermediate molecule called NADH. And this NADH enters the electron transport chain, where it then creates the final output, according to most scientists, which is ATP. So don't worry, I don't want you to feel overwhelmed by all of that. We're not going to get into all of these different mechanics today. You just need to know that glucose is processed extensively in the mitochondria, and that previously, most scientists believed that the goal of this processing was to generate ATP. This is the molecule believed to be the energy currency of the body. So we're going to keep on talking about the quantum elements, but as we do that, let's first turn to look at why this assumption from these scientists is likely incorrect and why ATP is basically fake news. So to do that, I want to look at our first quantum element, which is water and how water interacts with this cellular respiration process. To talk about this, we have to first turn to a Chinese-born water scientist named Dr. Gilbert Ling. There's Dr. Ling. In the 1950s and 60s, Dr. Ling conducted a series of experiments that challenged how we should think about ATP. These experiments showed that the energy stored within the ATP generated by the body wasn't nearly enough to power the body, not by a very long shot. He published a lot of papers over the course of his career asserting that ATP was not a feasible energy currency molecule for the body. He also presented an alternative idea, the association induction hypothesis. In this hypothesis, Ling suggests that structured water is the primary player in the body's energy grid and that ATP is playing a secondary role. So, even though no scientist attempted to prove him wrong, Ling was ultimately subjected to ridicule and ostracized within the scientific community. Most people thought that he was just some left field wacko. So sad. That is until 2013, when Dr. Gerald Pollack, pictured on the left there, released his book, The Fourth Phase of Water. So Pollack leads a water lab at the University of Washington, my alma mater, and this lab published numerous studies on a newly discovered gel-like phase of water. That seemed to be the only kind of water that is found in our bodies. This fourth state of water is biologically active, and our body maximally converts bulk water into this form when we drink. This fourth phase of water, otherwise referred to as exclusion zone water or easy water, carries an electric charge and is highly conductive. And even more crucial for our understanding, the mitochondria are what make this stuff, okay? So we've said a lot here. Let's unpack this a little bit and examine this fourth phase of water a little bit more closely. So another word for the fourth phase of water is exclusion zone water, or easy water. Here's how exclusion zone water works. So when water comes into contact with any surface, the water begins to separate its charge. Close to the surface, negative ions concentrate and form what we call the exclusion zone. And towards the middle of the water, the positive ions gather. This is what we call bulk water. Bulk water is another word for unstructured liquid water. It's not in the fourth phase, okay? So these exclusion zones work to repel all kinds of materials. That's why they call it an exclusion zone. It excludes things. So not only does it exclude positive ions, it also excludes substances like toxins, making it a kind of protection for your body tissues. So if you can picture this lipophilic surface being something like a cell membrane, if there's an exclusion zone around that cellular membrane, then it's going to repel toxins and stuff that isn't supposed to be there from coming into contact with that surface. So it's a great protective barrier. Now, the polarization of charge mimics a battery, which also has a negative end and a positive end, right? So it's this polarization, this separation of charge that creates a high potential energy. So the more polarized charge in the water, the more potential energy. In short, easy water is an easy means to store electrical energy that we can use in our bodies. It's likely the major energy player that Ling was looking for. So when we look at this cellular respiration process again, and just fair warning, we're going to be looking at this quite a lot, so prepare yourself. So we see that there are multiple places where ATP is being generated, and we're going to talk more about ATP in a minute. But we also see that a result of the electron transport chain, the last step in this process, is to generate water. And this water is not just any water, it is easy water, water with polarization of charge. So scientists used to believe that ATP was the star of the show here, and that this water was a waste product or a neutral byproduct of the process. And now, thanks to Dr. Gerald Pollack, we think it might be the most important part of energy production of all, is generating this water. Now, let's circle back to ATP. Is it useless? Is it a throwaway molecule? What exactly does it have to do with energy? So the mitochondria in your cells are constantly making energy for you by converting your food into electrically conductive water, or easy water. This is the battery of your body. But they're also making ATP. It turns out this ATP is a tool that your body uses to structure the water in your body. It's sort of like the dam that we strategically build in order to help harness the energy of your body's biowater rivers. So ATP is still playing a really important role in the energy cycle. We still want to have a lot of it so that your body has lots of capacity to create this structured water when it needs it. But it isn't the main event. It's a supporting player, an important one, but not the currency itself. You got me? So this is actually a really important mindset shift, and I'll tell you why. Because to create healthy stores of these electrical biowaters in the body, we need to do three things. We need to remove toxins so that the mitochondria can continue to be in cellular respiration and not in cell danger response. We need to prop up the mitochondria using quantum strategy so that the mitochondria can continue to produce this special water. And we also need to help our body to convert bulk water that we drink into usable, easy water. Okay, so the quantum element water is important to start with because it's what everything else is sort of built upon, right? Everything else we do should be a means to influence this easy water supply in the body. So with this in mind, let's now turn and take a look at air. How does air impact easy water and cellular respiration? And as we do this, we'll go ahead and check off this third agenda item on the agenda here, the fascinating relationship between water, breath, and plasma. All right, let's review our diagram here. So in this long and intricate process of respiration, we see that oxygen serves as an important input, and it's equally as important as food. It's quintessential. And the reason for that is that oxygen and the negative charge that it brings powers the electron transport chain and is really the whole reason how we are able to generate easy water over here. So oxygen is incredibly important. As we turn to examine air, just like I mentioned previously, we need to briefly turn back to water for a moment. So maybe you've heard before that we live in a fractal and holographic universe. The ancient Hermetic principle states that as above, so below, as within, so without. We see ratios and patterns that mirror each other across scales in our universe. So for example, we humans are 70% water by volume, and the Earth's surface is about 70% covered in water. The mineral composition of our blood also mirrors the mineral composition of the ocean. We're also 99.9% water molecularly, and the universe we live in is 99.9% made of plasma. So plasma might be a new word for you here, so let's talk about it. Plasma is the fourth state of matter. You know that there are three states of matter: solid, liquid, and gas. Plasma is the fourth state. Plasma can be thought of as a kind of very diffuse gas that consists of ions, not fully formed atoms. Plasma is highly electroconductive and it responds to electromagnetic frequencies. And plasma makes up all matter. The other three states of matter, solids, liquids, and gases, ultimately condense from plasma. So plasma is this diffuse electrical web of matter that surrounds us everywhere and condenses into other states of matter. So some common examples of plasma: lightning, the northern lights, nebulas, space, and solar wind. All of these are plasma. And according to Dr. Gerald Pollack, the guy who discovered the fourth phase of water, water is plasma. Okay, so now I want to pose to you a question that you might think is simple, but just bear with me. When you take a breath, what exactly is it that you think that you're breathing in? Got your answer? So a lot of you probably said air, and this is sort of true. Air isn't super specific, and I think that this is a time when we kind of need to be. Maybe some of you said oxygen. Oxygen is a more specific component of air, and it's very important from the mitochondrial perspective, but it's actually not a comprehensive explanation here for what we breathe in. There's something additional that we need to include here to be complete, and that is plasma. When we take a breath, we breathe in oxygen and the other gases that compose the air, but we also take in energy from the 99.9% of the universe that is made of plasma. Remember that plasma is everywhere. It fills empty space. So when we breathe in plasma, we're breathing in electricity. Remember that it's made of ions. And the Eastern esoteric traditions have known about this relationship between plasma and breath for thousands of years. They've named this electricity prana, chi, life force. And this is likely why breathwork is so central in so many of these traditions. So plasma must be included in our definition of what we breathe. But even oxygen ultimately serves an electrical role in the body. So this is an oxygen atom. And if you've ever taken a chemistry class, you'll likely remember there are certain ways that electrons constellate around different atoms according to the valence shells. So it's not that important, but what you need to understand is that oxygen atoms are always hungry for 2 electrons in order to be stable. So they always want to suck up 2 electrons from the particles around them. And it is this hunger for electrons that allows oxygen to basically power cellular respiration in the electron transport chain. The oxygen molecule attracts electrons that it can bond with like a big magnet. And this process generates ATP. This ATP also generates easy water, but the oxygen also generates easy water by bonding to 2 hydrogens and forming water. So if you're interested, the chemical formula that happens in this electron transport chain with oxygen and electrons and hydrogens is this. 2 oxygen atoms bond with 4 hydrogens and 4 electrons to form 2 molecules of easy water. So the supply of negatively charged oxygen to your body is absolutely crucial in generating easy water and energy. It literally powers the process. So let's return to our question here. When you take a breath, what is it that you're breathing in? Do you have a new answer? Here's a hint. You are breathing in electricity. We are electrical beings. The breath is electrical. This electricity powers cellular respiration that charges your easy water and contributes as a major player in the body's energy grid. Okay, so we know that water is the foundational bedrock of energy production and the star of cellular respiration. We know that air is an electrical input that powers this process. So now we're just going to briefly touch on these other two elements, not in the depth as with the other two, but just to understand how all four of these aspects are working together at the cellular level. So let's start with Earth. How does Earth impact this process? When we say Earth, really what we need to understand is that all matter carries an electrical charge. So the Earth's surface has an electrical charge. The food that we eat gets turned into electrons in the mitochondria. Our relationship with Earth is, like with everything else, an electrical one. So with that being said, there are a few places in this process that can be significantly impacted by interacting with earth and soil in a way that honors the electrical nature of Earth. First, the food that we eat ultimately gets converted into glucose and then electrons in order to harness that food's energy. So we can optimize this process by eating food that has more energy available to convert, right? So in short, that looks like fresh, locally grown whole foods. Processed foods, on the other hand, likely have a much lower electron store. Second, when we leverage the negative charge of Earth through things like grounding or earthing, we can provide an unlimited flow of free electrons into this electron transport chain, which really takes the burden off of our food for being the supply of electrons into this framework. So interacting with Earth in the proper ways and harnessing this charge can result in more electron flow and ultimately more energy. And that brings us to my favorite quantum element, and that is light. Gee willikers, do I love light. My clients know it's in all of my programming. But it's really been a transformative element for me personally. And let's take a look at an explanation for that. Why would light be so impactful for my biology? So when we're thinking about light and how it impacts cellular respiration, we need to focus our attention again on the electron transport chain and the easy water that it generates. Okay, so let's get into that. As I'm sure you're aware, there are many different kinds of light. Light is a spectrum, right? And all of these different types of light can impact our physiology in different ways, but I want to focus on two specific kinds of light here. And we're going to start with infrared light. So infrared light impacts a specific part of the electron transport chain called the cytochrome C oxidase enzyme. So this enzyme is responsible for the generation of ATP, an important player in our body's energy network. Now, in modern environments, most of us are deficient in infrared. It's missing from our lighting. But when optimal amounts are present, aka when we get outside, cytochrome C oxidase makes 300% more ATP. Okay, so our energy increases by at least 3 times over because of infrared light. No matter what you eat, right? So if you've ever noticed that when you're on vacation and you're outside all of the time, you don't need as much food, this is likely why. The cytochrome C oxidase enzyme is also responsible for generating easy water, which we also make way more of when we get optimal infrared. Infrared basically speeds this enzyme up. Okay, so just getting enough infrared has massive, massive implications for your energy production. And that's via this mechanism in the electron transport chain. Now let's talk about UV light. And this kind of light catches a lot of flack in the medical community because they say it causes cancer and skin damage. I take issue with these claims. My Mitomastery students will know. But cast those aside for a moment. UV light is absolutely crucial for setting your circadian rhythm. Your circadian rhythm is what tells your mitochondria when to do what. When you're awake, your mitochondria should be making energy. When you're asleep, they should be helping with detox. So when we don't get UV light into our eyes, onto our skin, our mitochondria get so confused and they try to make energy when we're trying to sleep and they try to detox when we're awake. So if your sleep cycle is all messed up, this is likely a contributing factor as to why you're not getting enough UV light. Another very important aspect of UV light is that it is the only kind of light that can generate melanin in the skin. In other words, it gives you a tan. And so melanin, despite what the crazy dermatologists have been trying to convince you of over the past couple of decades, melanin is actually a miracle molecule in the body. It's anti-cancerous, it's anti-inflammatory, and it's also a source of free electrons that your body can draw from whenever it needs them. So it's basically like a portable battery pack. Okay, so it's no surprise that having a portable battery pack of electrons that you carry around in your skin augments the generation of ATP and of easy water as well. All right, with that, we have covered all 4 of the quantum elements and how they impact the cellular respiration energy production process inside of the mitochondria. Pretty cool stuff. It always amazes me that such subtle and microscopic, teeny tiny stimuli can have such a major impact on our macro physiological processes, but they absolutely can.